sincerely apologize for your loss.
Needless to say, it's Waqas Rasul here, covering the nuclear program R28F2025.
Following the complete annihilation of your worldly assets.
Now, why I did it is both besides the point and question.
Given that an equiangled hexagonal of the same side length
Is just a regular hexagon,
which under group theory definitions contains 6 sides,
and therefore cannot be grouped or categorized within the classification of irregular shapes.
and within any objective framework, calling it not to scale is a severe understatement.
Due to the limiting characteristics of group theory definitions,
And so to impose the necessary rules on this Babylonian system,
containing not only incoherence within mathematical descriptions,
but also presenting a handful of options with a catastrophic potential to mislead millions, and so leading to the continuation of illiteracy.
of rationally complete solutions. And so given that the operational output of any irrational value with a rational number
Is still irrational,
we can see from the last option that the side length of the six-sided shape
is greater than the side length of the square, and option B is just the conjugate of the last option.
for which you can derive both irrational solutions from the quadratic formula. And so for the reasons given and the proof I will lay out, both options from the quadratic formula are eliminated. And so I will begin by marking the sides of the regular hexagon, where each side is of length x, such that x plus y is equal to 1. And from a purely Greek understanding of triangles, we know the square of the hypotenuse,
Is a double product of base times height.
and since length must be a positive value, we can derive the second condition as such. And so there exists no value for y that can subtract 1 from the positive root. And so option 1 cannot be rationalized. Finally, plugging in the half root in the first condition, we're just a half root away from one whole solution.
Since the second condition requires both the length and height of the triangle to simultaneously be a half
And a half root away from 1.
and such superimposed solutions can only exist within the imaginary plane. And so by way of elimination, we are left with only the third option, which is true if and only if the length of the hypotenuse is negated, under which condition 2 doesn't apply.